A very good morning to all. I welcome you all to this webinar on virtualization on behalf of Ekascloud. Myself, Dr. Savita, Senior Trainer in AWS. So I'll be taking you through this journey of what virtualization is. So let's try to understand its role in today's internet-faced world. So we'll be discussing with some real-time examples. So I'll give some real-time analogies which will make you understand on simpler terms what virtualization is. We don't have to worry about the word because it's quite lengthy and it might give us a tricky thought that this is going to be something complicated, but this is not complicated at all. So let's go through the webinar and let's try to understand. Okay. So what is virtualization and why virtualization? So to understand this, let me just give a simple analogy. Okay, so say you are a person and you are planning to own a mall. Name of the mall might be something. Say we have various malls, so we are planning to own a mall, build a mall. There is a person, say some person, some XYZ person. So he's trying to find the land. He's trying to find the construction company. So maybe the square feet of the mall is around maybe say 10,000 square feet. Let's say. So okay. So this particular person who's the owner of the mall is planning to open a cinema theater in this mall. So if this person is planning to invest from his pockets, so it might require crores, it might require amount in crores for him to invest from its pockets. So say around 1,000 crores. So he's planning to build a cinema theater, a film theater. So if he's planning to, yes. So if he's planning to build a cinema theater on this 10,000 square feet of mall, and if he's just provisioning that service to the users, to whoever the customers that he's trying to target, on the other hand, so who are like visitors to the mall, who's planning to take a ticket, book for a cinema, who's trying to see, so it might be a family, it might be a group of people, right, who's trying to visit the mall to watch the movie. And for this particular person, investing 1,000 crores from his pockets, building just a cinema theater in 10,000 square feet will be a loss or will it be a gain? I would always tell it would be a loss. Rather, this person can consider dividing the mall into various floors where one floor can uh, deal about clothing and fashion. So maybe the first floor, so this can be, so obviously there's going to be a parking given. So this floor may be ground and this will be the first floor. This floor can have the food court, which could further be divided into provision stores where the groceries can be purchased. So this person can further divide the mall into, say, products, selling products, that is dealing about the beauty products to target women audience or women customers. And maybe he can divide the cinema theater uh, into screens that could further be divided into two, which could further be divided into various screens. Screen 1, screen 2, so on and so forth. So that's how. So if I view this infrastructure, if I consider this infrastructure, if I'm planning to build my mall, and if I'm planning to segregate each of the floors into various, provisioning services, we call this as virtualization, as far as cloud computing is concerned. So this is what I can tell as virtualization as far as cloud computing is concerned. Why do I have to go for such a scenario? Obviously, I should not face any loss when I'm investing huge from my pocket. And also, I can make use of this 10,000 square feet efficiently. Resource is efficiently utilized. So what will happen if I build a mall like that? I can attract more number of customers. I can attract more crowd. So the crowd, whoever is trying to plan to book a ticket for a weekend, might go to the beauty product store. They would obviously go for the food court. They would obviously plan their groceries purchase. They would obviously get their clothing purchase done there. This is what is happening in the scenario in our day-to-day life. In the weekends, we go with the family to the malls, we watch movies, we finish our dinner, we finish our lunch in the food court, we buy the groceries from them, we go with purchasing our clothing. So that's how it's happening, right? So this 10,000 square feet is utilized efficiently. Along with that, I don't have to solely invest in just the cinema to pay my electricity bill and maintenance cost, security cost. I can divide it among all my services that I'm provisioning, all the partitions that I provide in my mall, where these users can access their services, which is efficiently used. So I don't have to go for hefty amount for paying electricity. I'll be paying for just 10,000 square feet. But all these services are provisioned within that. So this is the same analogy that applies for virtualization. So this is the reason that we have to go for virtualization as far as cloud is concerned, or any networking paradigm is concerned. Any computer related paradigm is concerned, it is always better to go for virtualization so that we don't have to waste the resources. We can efficiently use the resources. So there are various things that comes into the play when it comes to uh, virtualization, using the resources. So let's go one by one. So to talk about it in technical terms, I can view as a logical division. As you can see with the example I had given, I can divide the 10,000 square feet mall into ground floor, first floor, second floor, and fourth floor, which is going to be having various services running inside. Yes. Okay. So there is going to be division in the hardware. There is going to be partitioning in the hardware. Can some I can hear someone talking. Can you mute yourself? I'm just hearing my voice back again here.
So you're muted manually. Yeah.
Yeah, okay. Okay, so let's understand the necessity as far as computers is concerned. So when I talk about computers, it's not just the laptops that you're viewing in front of you. It deals with the servers even. So at the back end, there is a person who's serving you. See, you logged into this meeting. You access the Microsoft Teams. There is a server which is hosted by Microsoft at the end on the off screen, which is hosting these services from you through the internet. That's how it happens. So, how are these servers partitioned? So, we'll have to think whether these resources, the servers that is provided, is efficiently used. I would tell no, because there was a case in the history where servers were underutilized. So, they tell the servers were being idle for over 60% of time at the data centers. So let's talk about a data center first. So let me give you what a data center on a common terms, okay? So you as a person, so you're sitting right in front of your laptop. You access this meeting, which is Microsoft Teams. When you access this particular web page from your browser in your laptop, the request goes all the way to Microsoft data center. So your data center looks somewhat like this, which is again combination of various servers, collection of servers that will be serving the user. So there is a question whether this data center is being effectively used, just like your analogy of your mall that I told earlier. So they tell 60% of time it is underutilized. All the servers are being idle. So I can give you a very simple example. I can prove you this with something. So if you go to your, so I'll just, so if you can go to your search, so if you can go, you can just type Alt Control Delete. So it will take you to your task manager. Can you see my task manager here? Is this visible? Can someone let me know if this is visible?
Yes.
Yeah. Can you see the application? Yeah. Can you see the applications running here in my task manager? 8% of CPU is used, 70% of memory is utilized, 0% of disk is utilized, and network is utilized 0%. But my laptop's configuration is quite high. I'm using an ultra processor, which is beyond 1 i9, and I'm using 1 TB of hard disk, 0% is utilized. And my network is 400 Mbps, and the memory is 16 GB. My CPU, obviously, I told it's an ultra core processor. Can you see how idle my system is? And it is just running 1, 2, 3, 4, 5, 6, 6 applications. How do I view this? My resources are underutilized, right? So you will have to think it from data centers perspective. When there are huge number of machines connected with each other in the data centers, obviously there is going to be underutilization of hardware. So that is the need to go to virtualization. So when I virtualize my hardware, I can run more number of physical machines on a single physical machine. So I call that as a virtual machine. We'll see that with diagrammatical representation, what a virtual machine is. So if I can give you an example, if you had gone to PlayStations, have you seen driving a vehicle, driving two-wheeler, riding a plane with a simulated environment? Have you tried playing in a PlayStation with a simulated environment? So your virtualization is going to give you a simulated environment similar to that, where these users will be shown with a actual hardware, but it's not an actual hardware. So if I can tell in Tamil, இருக்கு ஆனா இல்ல. So அந்த மாதிரி தான் வந்து virtualization வந்து ஒர்க் ஆகுது. ஸோ நீங்க யூஸ் பண்ணுவீங்க ஹார்ட்வேர்லாம். ஆனா என்ன பண்ணுவீங்க அப்படின்னா ஒரு சிமுலேட்டட் என்வாயர்மெண்ட்ல யூஸ் பண்ணுவீங்க. So back then in the history, the requirement was to share hardware because it was very expensive. So back then, some in 90s and 70s and 60s, everyone was not having access to servers. We were not having laptops like how we used to have now. So there used to be a huge computer that is going to be very expensive, and common people were not allowed to access the computer. That is how it was. So investing more from your pockets for the hardware, but not efficiently utilizing it, is again a problem to be taken into consideration. And that's what led to the introduction of your virtualization. And the OS that would be running on your virtualization is called as a guest OS. We will see that in detail. So with virtualization, they tell 90% of hardware is utilized in the cloud data centers. So these are some technical terms. I'll tell you in detail with a pictorial representation, else it will be difficult for you to understand. Let's study about the history first. So it was introduced by IBM in 1960. So it started as a time sharing framework. So I'll tell what a time sharing framework is. Say, this is a laptop, and this particular is using the laptop. So I told you, my laptop is of higher configuration, but my resources are not efficiently utilized. So what I can do is, I can make my laptop, I can develop the infrastructure of my laptop in such a way that I can install some software that can enable more number of applications to run on it and more number of OSs to run on it. So what you would be having in your laptop, you might be having Mac OS, or you might be having Windows OS or Linux. So common users are going to be using Windows OS. So if I use a virtualization technique with time sharing framework or a type of technique, I can use Mac OS, Windows OS, Linux OS all at a time. So you call that type of paradigm as time sharing, where each OS would be given a specific amount of time to access the resources at a given particular point. But Mac OS will think it is using the laptop all by itself. Windows will think it is using the laptop all by itself. Linux will think I am using the laptop all for myself, but that is not the case. But I'll be running 3 operating systems simultaneously. So there is a technique called time sharing mainframe, which is enabling this for you. So the breakthrough was to enable resource sharing, where
sorry, ma'am. Okay, I have one question.
Yeah.
Can I ask now, or at the end of the session, can I ask?
Maybe we can have it at the end of the session, because I haven't literally gone to the core concept.
Okay.
Thank you. So what happens is the resources are efficiently utilized. I'm not wasting my resources, which means I'm improving the efficiency of my system and I'm reducing the cost. So I purchased the laptop for 1 lakh. With just 1 lakh, I am using Mac OS, Windows OS and Linux OS at a time. So I'm saving the cost. I don't have to invest on another laptop to work on Mac OS. I don't have to invest on a third laptop to install Linux OS on that. So how this happened is it started right from 1972. So the important functionality that is enabling virtualization is hardware assisted virtualization. So it comes all the way from 70s and we are in 2025. So we are in 2024, 5, right? Yeah. So all the way from 70s, we still have hardware assisted virtualization as the backbone of virtualization. So that is introduced from IBM system. So it started with IBM system 370. And now almost any laptop that you purchase in the market, it might be of any company. It might be Dell or HP or what do you call Apple or Asus, any laptop that you have. It comes with virtualization configured by itself these days. So you don't even have to configure it. It is enabled by default. So from 1960s to 2000, there were some ups and downs in accepting virtualization because so the graph was somewhat like this. Why? Because they were introduction of some distributed computing, clustered computing, which disrupted the performance. So few companies did not adopt it. Few companies adopted it. So there was there were some spikes in accepting it, and there were some downtimes in not accepting it. But later on, after 2000s, without virtualization, cloud computing is not possible. That was the case. And I can tell virtualization is the backbone of cloud computing because it cannot just virtualize a laptop, but a server at the back end, which is going to be having network functionalities, storage functionalities, and processing functionalities. Anything could be virtualized. So we'll see how that is happening. So this pictorial representation helps you understand how a traditional operating system runs on a server. So this is a traditional server, which means, say, this server is having some i7 core, plus it is having some 32 GB RAM, plus it is having a 2 TB hard disk. So this is your core, and this is your RAM, and this is your SSD, solid state drive. So this is the storage. We already know that. When I just install a single operating system on that, and if I'm just running few number of applications on that, so say application 1, application 2, application 3, so it goes on to application 10. So application 1 is maybe Microsoft Office. Application 2 is maybe MS Teams. Application 3 may be browsers like your Microsoft Edge, Google Chrome, Mozilla Firefox. And application 3 may be some heavily loaded software like say AutoCAD or any software like designing software. So not limited to, okay? So I'm running 10 number of applications. I would tell for i7 core, 32 GB RAM, 2 TB hard disk, this is still underutilized. So what I can do is I can go for a virtual server. I can go for a virtualization layer either above the operating system or below the operating system. There are two ways to do it. So this virtualization layer will make sure you can run more number of applications and more number of operating system. In your traditional server, you were able to run just one operating system. But here, if you install a virtual layer, you can have operating system 1, operating system 2, operating system 3. So I can call this operating system as guest OS. This is guest OS 1. This is guest OS 2. This is guest OS 3. My guest OS can run Linux, and this OS can run Mac OS, and this can run Windows. Further, this particular application, your operating system can have A1 to A10 number of applications. This OS can have A1 to A10, not limited to, okay? It can even move beyond more number of applications. This can run from A1 to A10. This could even be 50. This could even be 50, and this could even be 40 or more than that, 60. So what's happening is I'm efficiently utilizing my resources. So it's for the same configuration, I can do all these on my server or laptop. You can imagine as a laptop or a server. Obviously, your laptop is a minute server, right? A mini server running on your home right in front of you. So we need a technique, virtualization, with someone else. Who is going to do it? Question. Okay, ma'am, you had told different OSs can be run. Further, various applications can be run. We can scale up the resources. We can efficiently use the resources. But who's going to do it? Right?
Virtualization.
Yes, very good. So there is a software called hypervisor who is going to be actually doing this on behalf of you. See, this hypervisor technique didn't just start now. It started right when the systems were introduced. So I can tell you a fine example. See, you as a user, you're accessing your laptop, okay? So say you're opening MS Word. So you're working on this application. Say this is application 1. At the same time, you're opening, say, VLC media. You're listening to some song, okay? At the same time, say you're opening Microsoft Edge. So this is application 1, application 2, this is application 3. So when the user is accessing MS Word, at the same time when he's accessing a VLC media, and same time when he's working on some web application on Microsoft Edge, the user would be having a illusion as though MS Word is using all the resources by itself. But that's not the case. VLC media is using all the resource by itself, but that's not the case. Microsoft is using all the resource by itself. That is also not the case. What is happening is, say this is your processor. So this is your RAM. And this is your hard disk drive or your SSD. When the user is requesting to open MS Word, it will come all the way from your hard disk drive to the RAM to the processor. So the processor will process the instruction for you. So at that particular point of time, the MS Word gets executed. The resources are time shared. The resources are logged temporarily. Immediately, there will be some amount of resources allocated for VLC if you're trying to access it. So that will come all the way from HHD to your RAM to the processor. So this happens in nanoseconds, microseconds. You will not even be able to find it. So the processor is so fast that it can execute every instruction within seconds, nanoseconds. So it gives you an illusion as though each application is accessing the resources all by itself, but it is all shared among each other. So it starts right from your laptop. So we'll be using various applications. The same goes with your hypervisor when it is managing various number of OSs. So I can tell this as a guest OS 1, guest OS 2, guest OS 3. So this OS can be Linux, this will be Windows, and this will be Mac OS. Not applications, but think in terms of OS. So who is going to do that for you? Your hypervisor. So just like how your laptop is handling the applications, your hypervisor is going to be handling the OSs. But the hardware is going to be the same. There is not going to be any change in your hardware. In fact, you're going to efficiently use your hardware. So let's see from the diagram before. So I told how the virtualization functions, right? So you can have various guest OS running and further various application. So this package, this particular package, I can call that as a virtual machine. This is a virtual machine. Virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4, and this is VM5, and this is VM6. OS packed with its application to access the resources, which is VM1. And this is a OS packed with its application to access the resources all the way to the server. That is VM2. Similarly, all the VMs would be accessing the servers. And who is going to manage that? Your hypervisor. So you can even call your hypervisor as a virtual machine monitor. So what is a hypervisor? See, don't get confused with the word or terminology. It is a type of software. It's again a set of code. That's all. So if this is your hypervisor, it's again some set of code. So a software that is developed with some set of code, which is specifically designed to take care of all these activities of running various VMs on it. That's all. So say, let's take a scenario where a company needs server for 3 functions, okay? So a company is managing its emails with the email server, and it is running a storage capacity with the operating system. Secondly, it is running a customer facing application, which means an application is running on the company server to serve the customer. Say this company is working on a weather forecasting application. So the job of the web application should be to predict the analysis of weather and give it to the users when the user is trying to access this application, whether that particular day is sunny or if it is going to be rainy or if it is going to be cloudy. So we use weather application, right? So let's say this company is is hosting a weather application, and it is accessed by the users across the globe. So what the company requires? It requires an operating system to host the application on it. And obviously it requires a higher processing machine with higher power. And say it is running an internal business application which requires more random access memory. See the same analogy, if the company is only relying on 10,000 square feet to build the cinema theater, it will go in loss. You cannot efficiently use the resources. I'm just giving the scenario again with the same analogy. So what we can do is we can virtualize our servers. So a traditional system is going to be having a server which is handling only emails. A traditional system is going to be having a server which is going to be handling only the firewall servers. You can see only 30% of utilization is done here. 6% of utilization will be done. Might be somewhere between, might be lesser than that. It might go beyond that, but you cannot go beyond 90% of utilization when you're exclusively investing on these servers. So we can install a hypervisor where this particular server, one particular group of servers can handle emails at the same time, firewall services at the same time, and internal business applications at the same time. And I can go beyond 60% of utilization. Also, there is going to be high investment when it comes to your obsolete model, your traditional model. And if there are any updates happening here, say this server is going down, some hardware issue, or some disaster, the users will not be directed to this server. Even if they are directed, they cannot access their emails. But on the other hand, if I have virtualization, even this particular virtual server is going off, there would be another server which is again in a virtualized environment that will be hosting my emails. So it is like added advantage. I can even replicate my data across various servers, as well as I can virtualize the data and efficiently use my hardware. So low initial investment, and there is not going to be any downtime, which means say this particular group of servers are having some hardware issues, finding some difficulty in serving the user, right? The user is not able to access his emails. So at this particular point of time, what happens is you call that as downtime, which is a loss actually for us. You're not able to serve the users. Users should be always see there has never been a scenario where Google has gone down. There has never been a scenario where Instagram, Facebook, WhatsApp, whatever the social applications that you're using has gone down, right? Which means it is always up all time. And even if there's some downtime, they are managing it. How are they managing it? So these are the techniques which helps them manage, replicate the data across these servers, virtualize the hardware. Even if there is some lag, even if there's some error or bug in the hardware, there would be another server which is on a virtual environment running simultaneously to serve the user. So even if the server is not available, there is another set of servers on a virtual environment to serve the user. So even if there is downtime, even if there is some issue in the hardware, there is not going to be any downtime. Okay, so far so good. Any questions here? Anything to be asked?
Could you please go before 2 slides? I think.
Previous slides?
Yeah, exactly.
This one?
Before this one, the mainframe concept.
Yeah. This
Oh,
one?
yeah. Here, the second point. Yeah, time sharing mainframe.
Yeah.
Ma'am, time sharing mainframe means that the in the virtual machines, the time each machine will be allotted some time to do some task, or
Yeah, exactly. Time will be allocated for each machine. Each virtual machine will have its time within which it has to execute and leave the resources.
so it was previously like that.
Yeah, so there are various algorithms that decides how long one particular virtual machine can access the resource, like scheduling algorithms. So this will execute based on the scheduling algorithms. VM1 or VM2, VM3, VMN.
Is it now also like that, or
Sorry?
yeah, now also it is using same time sharing concept?
Yes. It is still used. It is still
Okay,
used. Yeah.
okay. Thank you.
Yeah. But we will not get to know from the user's perspective. Okay, so if you're a user, we will not get to know that the systems are time shared. we will have an illusion as though all the processes are running simultaneously, concurrently. From the user's perspective, we will not get to know at all how the machines are working. Okay, so we have two basic types of hypervisor. One is type 1 hypervisor. Second is the type 2 hypervisor. We can call the type 1 hypervisor as a bare metal hypervisor. Why? Because, so this is your hypervisor and you install your hypervisor directly on your hardware. And upon that, you can configure various guest OS. OS 1, OS 2, OS 3, and to N, might be any number. So when you put it directly on the hardware, you call type 1 hypervisor or embedded hypervisor. On the other hand, when you have your hardware resources, which is again your processor, your RAM, your SSD, the same thing is going to be here. When you have a hosted operating system and upon that you install a hypervisor, and upon that you're going to be having some guest operating systems. You call that as hosted hypervisor. We will see the demonstration of hosted hypervisor at the end of the session. I will show you a small demonstration. So there are various software which will do hosted hypervisor paradigm, and there are various software specifically designed to execute your bare metal hypervisor paradigm. These are some examples. If you type 1 hypervisor, VMware hypervisors like vSphere, ESXi, ESX, Microsoft Hyper-V, Oracle VM Server, Citrix Hypervisor, and AWS Nitro Hypervisor. So this Nitro Hypervisor, I would tell, is the backbone of AWS. We will see how it is playing its major role as far as AWS is concerned. So this is a bare metal hypervisor, and this would be your hosted hypervisors. So I'll be giving you some demonstration on Oracle VirtualBox. I already have it configured in my system. So I'll show you how various operating system runs at the same time with the hosted hypervisor. So these are some other examples of hosted hypervisors. So I would be having an operating system here, basically, which is a core operating system. And upon that, I will be running various operating systems. OS 1, OS 2, OS 3. So here, I would be having my hardware. So these are my hardware. I would be configuring my hypervisor, which is the VMM, virtual machine monitor, directly on the hardware. And upon that, I can run various operating systems. So this operating system is called hosted OS, a host OS. So I have some experience in working on ESXi and Citrix hypervisor, where you'll have to go to the data center and you'll have to connect the data center server with your monitor, and you'll have to boot the CD, which is the external medium. So with that, you'll have to boot the hypervisor, and from there you can host the applications that you are developing across your campus. If you're working in a campus, if you're working in an organization. So it's again an interesting topic. Okay, so how to enable VTX? So let's understand what VTX is first. So VTX is trying to enable your. So VTX is trying, so it's an option which tries to enable virtualization in your laptop. You can do it even in your laptop. So we've been discussing about it till now, right? How to do it in your laptop. So if you are using an Intel Core processor, you will have to enter the BIOS settings first. while you're restarting your laptop, so you'll have to press F2 button. Mine is a Dell, so I have to go with F2 button. So if yours is HP, then you may have to go with F10 or escape keys. You have to press it while you're booting your laptop, and you'll be taken into a page or a tab which you call as the security tab. And under your security tab, you'll be having an option called VTX. So if it is an AMD processor, you will be having AMD V. So if it is an Intel processor, you would be having VTX as the option. You will have to switch from disable to enable. So once that is done, you'll have to save the settings and it will look somewhat like this. So if you move into your BIOS, so this is into your BIOS. So if you move into your BIOS, so with the virtualization technology is called VTX. You have to enable it. So can you see it here? It is VTX. So once I enable it, now my laptop is in a ready condition to install VirtualBox hypervisors on it. But as far as your laptops are concerned, you can work with only hosted hypervisor because we already have an operating system. We already have a host OS. So upon which you would be installing the hypervisor, VMM. And then we can run various OS. So as far as our domestic laptops are concerned, we can work only with hosted operating system if you already have an operating system. But as far as data centers are concerned and AWS is concerned, they go with type 1 type of hypervisor, which is bare metal hypervisor. You can see it here. Because they are going to be working on the servers, directly on the servers in the data centers. So AWS data centers. And this is faster compared to your type 2 hypervisor. It's the performance a bit fast compared to your type 2 hypervisor. And that's why AWS goes with type 1 hypervisor. So AWS uses Nitro hypervisor, which uses a technique called kernel-based virtual machine. So this kernel-based virtual machine is a type 1 hypervisor, which is built on Linux kernel. Why Linux kernel? Because it is highly secured and robust compared to other operating systems. And it is a hardware-assisted virtualization, which is using HVM as the mode of operation, which means it is a type 1 hypervisor, which is bare metal. So my hypervisor is going to sit directly on the CPU, memory, disk, network, everything is going to be virtualized. And how will it be displayed to the user? So they have an emulator called QEMU, Quick Emulator, that will emulate the environment to the users. So say this is AWS data center. So there are various users trying to access the AWS services. So user 1, user 2, user 3, user 4, 5, not limited to. Each user would be having an emulated environment. So emulated environment in the sense, each user would be having his own console, AWS console. Thinking that the user is the whole owner of the data center, but no, there are millions and millions of users, millions and millions of organizations and enterprises who have tied up with the AWS data center and using their services. But each of the organization would be having its own console and own emulator, which is making these users to access the resources. So there will be various services.
So, what is the difference between simulation and emulation?
Simulated environment is, see, there is something called cloud sim. So in a simulated environment, it's a bit same, but emulation, I can tell it as a bit higher in its UI and the features. Here I can have what do you call the resources viewed as some templates. Say, if I would want to design a data center, there is a template available for data center in Cloud Sim. If I would want to host a cloudlet, there is a template available for hosting the cloudlet. So if I'd want to host say a user, say I would want to host a user, I would like to develop an architecture in Cloud Sim. I have a template for it. And I'll have to give some set of codes. But an emulated environment is going to show the same copy of your physical infrastructure. Simulation is like having a practice, a blueprint before trying to configure the same machine on a real-time environment. But this is not a real-time environment. But your emulation is, this is going to show the picture of the exact data center to the users.
Okay, right, understood. So simulation is just a dummy, like where we can use it as a like a very layer where we can just practice. But emulation is a real-time environment.
Real-time environment. It will mimic the real-time mimicking a real-time environment.
Okay, thank you.
So yeah. So KVM, HVM. So these are the two important techniques which are used. So kernel virtual machine, it's just going to be using hardware assisted virtual technique, which is again going to be providing you high performance paradigm, and that is how AWS is working. So Nitro cards plays an important role. So as I told you, it is again a set of, it's a board, it's a chip board. It looks like a chip board, which is a hardware component that is going to be attached with the data center's main server, but it will be offloading the task from the main servers. So if I have the data center here, one second. So if I have the data centers here, if I have this Nitro card attached to the server, a particular server, say this is in rack 1 and this is in rack 2, this is in rack 3. So this is a Nitro card attached to rack 1. Whatever the task that this particular rack is receiving from the user, say there are n number of requests from the user, this card can offload the task. It can process it internally. Again, your virtualization is enabled with this Nitro card. So your network load will be taken care by it. Storage load will be taken care. So it is like freeing up the load from the server in a rack. Say this is a server. And that's how the Amazon EC2 instances are created, and that's how it is running. So the simple chip, which looks very small, is actually the crucial role player, I would tell. So there are various Nitro cards available for VPC specifically designed for virtual private cloud. This is for your elastic block storage. So this is like your internet. So in an internal internet, which is on an on-premise environment. An elastic block store is somewhat, it's going to be having your hard disk drive and your SSD. So when it is provided by AWS, you call it as elastic block store because you can scale up and scale down as and when required. No, scale down is not possible. You can scale up. And you have something called instant store. It is again a storage medium that is going to provide a temporary storage for whatever the data and applications that you upload in your EC2 instance. A card controller which controls all the other Nitro cards. And a security chip to ensure the encryption and decryption of data is appropriately performed to protect the user's data. And who is doing this? Annapurna Labs. AWS is in tie-up with Annapurna Labs, who is the right hand for AWS. It is an Israeli-based microelectronic company. It is having its own Silicon Valley innovation. So this arm is totally supporting AWS in developing Nitro cards, designing Nitro cards, producing Nitro cards. All those are taken care by Annapurna Labs. So this is how your Nitro card will look like. So it's a very small card. It looks like it has some chips in it, designed specifically for offloading the task from servers. So if it is a SSD card, it will look like a SSD. If it is a network card, then it will look somewhat like having its network features as how we have it in our laptops. So we have RJ45 jack, right? So it would be having some jacks in the card. Similarly, for various purposes, various cards are designed. So it's done by Annapurna Labs in association with your AWS. Okay, any doubts so far? Any questions? Anything to be discussed? Okay, so there is this innovation that keeps happening in the environment. So which is between the cloud, virtualization and containerization. So it started all the way from the cloud. It went with virtualization hand in hand, and we are landed up here with something called containerization. If I can say cloud computing as a service which can provide shared resources over the internet on pay as you go pricing model, where the business don't have to own any physical data center, not required. I can register myself to the AWS services. I can use it based on the pricing model that they provide to me. I pay for only what I use. But on the other hand, virtualization is the backbone of cloud computing, as I told. So virtualization means they are going to be using their own data centers that will be virtualized with these type of hypervisors, and multiple virtual environments can be generated out of it, where the businesses can access their APIs and cloud resources through their APIs. See, APIs have become very trending these days. With just APIs, we can get few things done. We don't have to literally go with developing the whole software code. So containerization is the current trend where, so I can tell it from here. So let me show it here. So I told you these are VMs, right? This is VM1 and VM2. When I further put it in a package of containers of only the required code that I need, with some libraries and APIs, you call that as containers. I don't even have to go for virtual machine. This is again a finely granuled package. So if I would want to access this container as a user registered in AWS, I can just pay for this container service and I can use this container service through APIs. which is application programming interface. I don't even have to go purchase a VM. Not required. So that's about containers. So that is actually happening in the trend. Okay, so this will again further reduce the cost for us because we are literally going to be accessing only the required configuration files, libraries, and dependencies attached to the application. So we have various types of virtualization. So when the applications are virtualized, you call it application virtualization. When the server is virtualized, it is server virtualization. When you have a desktop virtualized, it is a desktop virtualization. On the other hand, storage, data, and network. So you can see it here in the diagram. So you have an operating system and you'll be having an application running if it is a traditional server. We already discussed it. So when you install a hypervisor on that and your server is being used to serve various other functionalities or functions, you call that a server virtualization. We don't have to micromanage and the complications are going to be really less. So the physical servers are viewed as small virtual servers. So this is what you call as instance in AWS EC2. So each instance or virtual server thinks it is running on a operating system which is all to itself, but that is not the case. It is all shared among each other. So your virtualization on server will give you a virtual machine which can have its own guest operating system and you can have an exclusive application running on it. And you can have a virtual machine too, which can have a VM, a guest operating system. So VM is again the hardware resources and an application which is exclusively running on it. Your network can also be virtualized. How can your network be virtualized? Say, so this is your laptop. You're trying to access Google Cloud, okay? Google Data Center. So when you're trying to send and receive requests, it is obviously going through the cables, right? The fiber optic cables. Even these cables can be virtualized, where you can send and receive requests from many number of users across the globe. So when you are virtualizing the network connections, which is the physical connectivity with the software application, which is defined by your network functions, where your firewalls, routers, and load balancers, everything can be virtualized with just some piece of code. And there are some specific software available in your network functions and software defined networks, which is going to control the traffic with some set of software. You don't have to invest on bucks and bucks for your physical infrastructure. Your software can do, which is again some set of code, which is a piece of code, which can virtualize the network environments for you on your behalf. So you can improve the speed of your network, security features are inbuilt, and flexibility, allowing multiple users to access the same physical network at a time. And this is an example of storage virtualization. So your storage can also be virtualized where various number of users can access the same set of storage across the globe. So the user thinks as though the storage belongs all to himself. No, but it is actually shared among all the users. So you call such type of storage as virtual volumes. And again, your virtualization layer comes into the role. There are some set of software code available to perform storage virtualization, particularly. So I can give a very fine example for this. Say you are trying to access Google Drive. So for application virtualization, you're trying to access Google Drive. So this person A1, A2, A3, say 3 persons are working on a collaborated project. You're trying to access Google Drive and you're working on Word file in Google. Each person's laptop will be displaying this particular Word file to him, right? That's how it happens. Which means this is a single application that is hosted by Google, MS Word, sorry, Google Docs. So this is Google Docs. Though this is a single application, it is providing the users with each copy to the user. So the A1 user will be able to see a copy, A2 user would be able to see a copy, A3 user would be able to see a copy, which means the application itself is virtualized, which is decoupled from your net, your computing resources. So computing resources in the sense your processor, RAM and storage. So this will be your processor and your RAM and your storage. So it is decoupled. How it is decoupled? With your virtualization. So each of your application is viewed as a actual copy by the users, but that's not the case. It is still running exclusively from the resources. It is decoupled from the resources. So even if this user's copy is crashing, this copy will be there. If there is some issue with the laptop of this user, he has tried accessing it, there is a crash in this bug in this file, still there is a copy available with the other user and the other user, so on and so forth. And we have something called desktop virtualization. A fine example is when you're working from home. So when you have a home office, your companies might be having a desktop which is provisioned to you on a virtual environment. You can log into the company's portal right from your homes. So when you're working with AWS and when you're trying to initiate a virtual server instance, you can see there is an RTP desktop that gets downloaded to your system. You can access this virtual copy, which is a virtual copy. You can access it from your system. It shows you as though you're accessing an actual desktop. That's desktop virtualization. Your data can also be virtualized. So this is what I told when we discussed about containers, where same set of data will be viewed across various users. Say there is a stock market, healthcare data, and weather data, where users will be accessing the data from a single source, which will be virtualized and that will be provisioned to users across the globe. So if there are some set of users using cloud SaaS application particularly, so they will be virtualized and will be provisioned from there. If there are set of users who are using big data, NoSQL services, then those set of users will be provisioned from that particular group of data. So it is again viewed as a data warehouse from where they can collaborate with each other and access their required services. So with that, the theoretical explanation is getting over. Any questions? Anything to be discussed in particular?
So the Amazon will support all this type of virtualization, right?
Amazon is working only with virtualization. Without it, it cannot.
Yeah, these all the types it uses.
Yeah, all the types of virtualization are supported.
Okay.
But their main focus would be server virtualization.
Can I see the first two, three slides?
Sorry?
First two, three slides, can I see?
I cannot hear your voice. Your voice is not clear.
Can I see first two, three slides?
First through 2-3 slides. Okay.
Yes.
So here I discussed about why do we have to go for virtualization.
Yes, yes, I joined that particular Facebook. Thank you.
So the reason for going is the resources are being underutilized, which is just 60%, and we shouldn't leave the resources underutilized. So after virtualization, we can achieve 90% of hardware utilization. And history, I discussed about the history, and I discussed about the traditional server and a virtual server.
I already see. Hmm.
Any
What
other
is it?
queries? Yeah. Any doubts? Yes, go ahead. You were asking something. No? No queries?
In the containerization, we can use the particular type of data, right, madam? Particular type of data. You told that.
Yeah. You want me to talk about containers?
Containerization, we can able to access particular type of data, big data. You told.
Yeah. So everything can be put in a container. So, see, I can give a very fine example for this. See, if you have experience in cooking in the kitchen, you can see you have a storeroom, right? We would have a storeroom where we store all the provisions in the storeroom. So when you're cooking in your kitchen, it is not that you'll go to the storeroom every time to access the provisions from the storeroom, right? So what we do, we put it in a containers, all the cereals, spices, pulses, we put it in a container and we keep it near us so that it is easy for us to access when required. So you can view your containers like that, where you don't have to go all the way to your VM, all the way to your applications, all the way down to your servers. The containers are decoupled. They are decoupled from the servers, but still they have some libraries, dependencies attached to the servers. When you import it in your system, you can start using it. So AWS provides these services with something called microservices. This is actually 1 second. So this 1 second. So they provide with something called microservices, which is provided with something called with the paradigm which is called function as a service. You can just access the function that you require, not the entire virtual server. It can still save your cost and time. Yeah.
Thank you.
Any questions further?
Which AWS service support containers?
See, we have something called EKS, Elastic Kubernetes Service, and container services we have in AWS that provide the container services to us. We have something called Dockers and containers.
So is that comes under development side or?
See, it is very much useful as far as development is concerned. For developers, it is very much helpful, where they can provision the resources across the globe, and there are going to be some containers which will be scaling their application. So say a developer is trying to host, or say organization is trying to host their web application across the globe, and various users are going to be using the application. Say there is a seasonal change, okay, some big billion offer or Diwali offer or Christmas offer or New Year offer is happening. When this particular application is hosted on the server, so say this is the application. Okay. And when there is an increase in number of users, So these applications can scale automatically by themselves, scaling the resources automatically by themselves so that the users are serviced even if there is an increase in demand. So to do that, containers plays an important role. In real time, this is how it will happen. Yes, question. Did I answer your question or is it still not cleared?
Yes, it's clear. I just want to confirm currently I'm doing the associate certification related
Okay.
course. So is it covered the container in that?
Yeah, containers are also covered. Kubernetes are also covered in that.
An associate, right? Okay.
Yeah. Yeah.
Okay. Thank you.
Any further questions? I will just show you a demonstration of a virtual machine here. Okay, so I have installed Oracle VirtualBox. So if you want to virtualize your desktop, you can install your Oracle VirtualBox from Google. You'll have to just give Oracle VirtualBox latest version for your appropriate operating system. So I've already installed it. So once this is done, then you may have to go to Google and you'll have to go search for Ubuntu ISO image. Download 64-bit. If you want to install Ubuntu operating system. Else, if you want to install Fedora, you can go with FEG, Fedora ISO image. So you can go to Fedora Workstation project. You'll have to download this image. It will take some time. There are two versions, desktop version and server version. So once you download the image, I already have it with me. You can start booting it in your machines and you can run. See, I have 1, 2, 3, 4, 5 operating systems running. This is a hosted operating system. So I'll try to boot the system. So I've already done it. So I will select the system and I will start the system, which is the operating system. So powering the VM up. So it is getting started. Okay. So I'm in my system. I had done some practice earlier. I can see the server version is available for me. So if I would want to make a directory, I will just make a directory here. So it is very small actually. Can you see it?
No.
So I will create a directory with mkdir vmm. I will list the directory here. So I can see vmm is here. So I'll try changing to this directory cd vmm. So I'm inside vmm. So I will try creating a file here, touch xyz. So if I list the file, I can see the file here. So which is just a basic operation I can do with Ubuntu. If I want to save the state, I can save the state. When I close it, I can either power off the machine or save the state. So next time when I power on the machine, the state is going to be retained. So this is another OS, which is Debian, which I installed. So I can start this. So it will take some time. Okay, so I had already given my username. So this is actually not authenticating me. So some issue with the authentication. So the password is all given fine, but there is some issue with the authentication. So even if you can do it from your end, you can install a virtual box, you can try booting the ISO image of Debian, and you can try authenticating, you can try executing it. So this is C. Can you see the battery icon here?
Yes.
So this is, yeah. So this is virtualized from my physical machine. Can you see the battery icon here? This is my actual physical machine. This is just emulated over here. So if the battery is low over here, obviously it is also going to be showing low, which means this machine is sharing my resource. The VM machine is enabling my guest operating system to share the physical resources. So actually this is not authenticating me, so I will not go ahead with it. I'll just tell you how to boot the operating system. I'm not going to save this. Okay, so to boot the operating system, you'll have to go to new. You'll have to go to new. So new. So here you have to give the name of the operating system. Say if you would want to boot Ubuntu. So I'm giving the name of Ubuntu, and I'll have to select the ISO image. So I'll go select the ISO image. I'll go find the folder here. It's somewhere here. Okay, so this is the ISO image which I had downloaded. This is the disk image format. This will be in disk image format, which means your entire operating system is archived as an image. It's frozen as an image. And you can see the capacity of the image is quite high because it's an entire operating system. So if I select this and if I open it, and I'll have to give the type of it is already taken. The type is Linux and the subtype is Ubuntu, which is a 64-bit operating system. So what is happening here is not allowing me. Okay, fine. I'll perform it again. Add. 1 second. New machine. I'll go with Linux. I'll go with Ubuntu here. So you can have various options you have it. You can have any of the OSs of your choice. So I'm going to go with Ubuntu, which is a 64-bit operating system. I'm going to give the name Ubuntu 4. And I'll choose the file from here, ISO image from here. So this is the ISO image I have. Okay. So the name was the issue. I already have a system with Ubuntu, so I'll have to rename it with some other name, unique name. So I'll go with next. Here it will ask for the password, username and password. So the username is going to be VBox and password is going to be, I'm just giving it as Ubuntu. So next, here you'll have to define the hardware requirements. So how much memory you require. So this is around 2 GB and how much processor, 1 virtual CPU or 2 virtual CPU or 3 or 4. So depending on that, you see how many number of CPUs you're giving here, that many would be provisioned from your physical resources, which is your laptop for this particular operating system. And if you want, you can even scale up the resources. So 3 GB, 4 GB, no issues in that. So I'll go with just 2 CPU. So 2 CPUs are enough. I'll go with next. So your virtual hard drive or hard disk is going to be allocated 25 GB and go with next. If you finish, the installation will happen. I'm not going to do it. I already have it here. It is again going to take a lot of time because it is like booting an operating system right from the scratch on your physical machine. So it will have all the options of giving the time zones, disk partitioning, DNS server installation. All these processes will happen. I'm not going to do it, okay? So I'll just cancel it. So I'll just show you. So I just showed you how I booted the machine and it is available for me here. And I can even go ahead with more number of OSs, not limited to. And we have one more interesting option here where I can import and export this particular operating system as a node as such, as a package. So if I go here, I'll close this machine, I'll save the state. Second. So if I want this particular operating system to be imported, so I'll have to select the operating system. You have an option here in settings, no, not in settings. Okay, so import appliance, export appliance. So I can export this appliance, which is Ubuntu 2. If I go with next, so I can select the network configuration. I'm going with NAT gateway. And if I go with next and if I perform finish, it will be stored as a node. So it will start writing the entire operating system as a node. So I'll show it to you here. So if I go to Oracle VirtualBox, I had already imported it here, so I can see it here. So this node, can you see this node? I imported this node from my machine, which was done some 5 years before. So if you have to import that node, then you'll have to go to File, Import Appliance. You'll have to choose that node which is available. So can you see here, Ubuntu 2, which I'm just trying to export now. But if you already have a node which you've imported, it will be displaying with an icon shown here. You can import it, you can open it, and you can start working on your machine. This is particularly used when you would want to have some operations to be retained in your operating system and you have to migrate your data from one machine to other machine. To make your setup a highly available setup for disaster recovery, on such cases, you can go with such options where your entire operating system can be migrated from one node to other node. So can you see KVM para virtualization? So this is the technique we discussed. Almost all the operating system will be using KVM assisted type of virtualization. So, okay, so with that, I'm going to end the session here. Okay, so any questions?
Can we have this presentation? Actually, there are a few new concepts. If you provide it, it will be very good for
Yes.
a reference purpose.
Okay, fine. I'll have to discuss with the team to share it. If
Okay, ma'am.
we have
If it is possible, please.
yeah, if we have the privilege to share, then no issues from my end.
Ma'am, also, what about the recording? Actually,
It is recorded. It is recorded. If you want, I will discuss with the team and I'll share it with you.
Super, ma'am. Thanks.
Any other questions, queries?
That application you showed me, right? The practical demo.
Yeah.
Is it a virtual box manager, right? How to install that one?
Yeah. So yeah, let me show it to you. 1 second. So go to your Google. So here you'll have to type Oracle VirtualBox for Windows. Mine is Windows 11. So you can download it from here. It's a hypervisor. What type of hypervisor? Can you tell me what type of hypervisor is that?
Type 2.
Very good. It's a type 2 hypervisor. Any questions further? Any doubts to be clarified?
Ma'am, could you please recall the difference between type 1 and type 2 with real-time examples? It would be nice.
Okay. So type 1, type 2 hypervisor, right?
Yeah.
This one, right?
Yeah.
Okay, I will explain it on the whiteboard. So maybe that will be easy for you to understand. The screen is visible, right?
Yes, ma'am. Yes.
Yes. So what happens here is, okay, so first let's draw or let's pictorially represent the computing resources. So this is your processor. This is your RAM. This is your SSD. So this is the basic hardware configuration of your laptop. Any laptop or any server is going to be having three basic combination of these, right? With some network attached to it. So when I install my virtual machine monitor, this is my virtual machine monitor. When I install it directly on my hardware, further, I can have many number of guest OS. This is guest OS 1, guest OS 2, guest OS 3. You call this type of hypervisor as type 1 hypervisor, which you call it as bare metal or embedded hypervisor or virtual machine monitor. Hypervisor is also called as a virtual machine monitor. Why bare metal? Why it is called bare metal? Because you are directly installing and configuring your hardware resources, which is going to be having the hypervisor sitting on it directly. This will sit on the hardware resource directly. On the other hand, so type 2 hypervisor, or I can call it as virtual machine monitor. So what happens is you have your same hardware resources. So it's going to be your processor, this is going to be your RAM, and this is going to be your hard disk drive or SSD. You're going to be having a host operating system running on it first. And above that, I'm going to install my virtual machine monitor, which is your hypervisor. Further, this will provide me all the guest operating system. Guest OS 1, this is guest OS 2, guest OS 3, guest OS 4. So this operating system can be anything. If you are using Windows, you have to install the virtual box, which is compatible with Windows. If you have Mac OS, then you have to install VirtualBox, which is compatible to Mac OS. And if you have Linux, you have to install VirtualBox, which is compatible to Linux. That's how it functions. So you'll be installing various operating systems. So you'll be having various operating systems on it, right? See, Linux might be requiring different configuration. Linux has various flavors in it: Ubuntu, Kali, Linux, Fedora, Debian OS, and Mac has various configurations. Windows has various configuration. So though your underlying hardware is different, without any issues, you can run various operating systems on it. There's not going to be any compatibility issues. So who's going to take care of it? Your hypervisor. So it's going to be either this way. So if you put the hypervisor, so RAM, processor, RAM, storage. So if you install your virtual layer, so this is your operating system. Okay, so let's say this is your operating system. If you configure your hypervisor below your operating system directly on the hardware, that is your type 1. If you configure it, so say this is your virtual machine monitor above your operating system, you call it type 2. Finally, the output is going to be the same. You are going to be having more number of guest OSs.
So type 1 is fast compared with type 2, right?
Yes, this is faster. Why it is faster? Because it is directly communicating with the hardware. It is close to the hardware.
Thank you. It's clear.
Any queries further? Okay. So good meeting you all on this seminar. So hope you had gathered a few data. So I tried to cover as much as possible from my end. So hope your process of learning continues with that. So happy learning to all. Thank you. Thank you.
Thank you.
Thank you, madam.
Have a nice